All right. Good day. Um, Welcome to Physical Sciences session, where we're going to discuss electricity from the basics. Um, Make sure that if you don't understand, just open up your mic and communicate with me. So this is where we're going to study electricity from the basics, okay? And then we're going to learn more about the three parameters. We're going to learn about the resistance, the voltage, as well as the current. So those three parameters, they're very important until you get done with your grade 12. So now let us start. What is current electricity? Now, when you think of electricity or when you think of a current, think of charges of a substance. Now, let us start here. What we see here on the picture is I want to focus on this picture of a wire, which is a good conductor of electricity. Now, this picture that has a wire in it, we can see that it has a plug. So when you plug this on the socket, what's going to happen is there is going to be a flow of charge inside of this current carrying conductor. I call it the current carrying conductor because we know that it's a good conductor of electricity, right? So now this is what is happening. Say for example, I have a wire, right? This is just a simple diagram of a wire, and then maybe I pick a specific portion and then I magnify or I zoom that specific portion. Now, this is what you're going to see inside of a wire. Now, a wire, it is an example of a metal. And we say that the metals, they are good conductors of electricity. You know why? Because they have free moving electrons. And these free moving electrons, we call them the delocalized electrons. Now, the picture that we see over here, for an example, we can see that we just zoomed or we just magnified a structure of a wire. So now what we see here, we see the small particles or the balls, form of balls particles. We call these particles the electrons. Now the electrons, they are negatively charged. So it's easy for us to call the electrons charges because they are negatively charged. Now, these electrons, because they are negatively charged, then we're going to consider them as charges. Now, this is what is happening. When we talk about the current inside of a current carrying conductor, it's when these electrons that are found inside of a wire move in a certain path along this current carrying conductor. So that's what we mean by a current that flows inside of a current carrying conductor. Okay, so remember it's a wire. It has electrons like this. I mean, like when you zoom it under microscopic level, when you zoom it, you're gonna see something like this. These are the electrons, and these electrons, they are close to one another and they move, they vibrate. But if there is a charge, I mean, if there is a source of power, therefore these electrons, they're gonna vibrate and interact with one another and start to flow inside of the current carrying conductor. Hence why we say a current, it is the rate. This is the formula that we use for current. We say I is equals to Q over change in time. We say that current, it is the rate means time, okay? Current, it is the rate of flow of charges. So that means Q, it simply means the charges. So the rate at which these charges flow inside of a current carrying conductor, that's what we mean when we talk about the current. I hope that was clear, okay? So this is just the microscopic level of how does the electrons actually look like inside of the current carrying conductor. So here we just say, what is the current? Electricity, the flow of moving charges, usually carried by moving electrons in a wire, which is what I have just explained, okay? All right. Now, since we already spoke about the currents, we need to understand where is current actually in existence. Now think of the circuits. We have different types of circuits. We have different connections of the circuits. For example, we have the series connection of a circuit. We have a parallel connection of a circuit. But now when you think of a circuit, what are you thinking of? Have a look at this diagram over here. This is a simple schematic diagram of a circuit. A circuit, it is composed of components. But let's have a look at the components that are presented in this diagram over there to talk about the circuit. We have the battery, we have the copper wire, and a copper wire is a good conductor of electricity. That means copper conducts electricity throughout the circuit. And then we have the light bulb over there, which will indicate through that there is a current flowing inside of this circuit. We have the light bulb over there. Okay, so this is just a simple schematic diagram of a simple circuit. Now, when you talk about the circuit, what are we actually talking about? We are talking about a path in which charges, I have already explained what do I mean when I talk about the charges. Meaning a circuit, it is a path in which charges continually move through a complete loop. This is a loop, right? It's a complete loop. So the charges, they're going to move around this loop. The charges, they're going to move around this loop. And it's a complete loop because it doesn't have and leakage, it doesn't have an opening. Okay, it doesn't have any opening, so that's why we say it's a complete loop. Return to the original position and cycling through again. So circuit, it's a path where there are charges that are continually moving inside of this closed loop. Okay, that's what we mean by a circuit. Now we need conditions for electric current to flow inside of the circuit. But what are those conditions that are needed for electric current to flow inside of the circuit? We need a source of energy, which is a battery in this case. We need conductors in a circuit, in this case, which is copper wire. This is what we need. And then we need a closed circuit, not an open circuit. We need a closed circuit. For example, what you see over here is for a fact that this light bulb, it is bright. What does that mean? It means that the circuit is closed because we know that a light bulb, it is a device that consumes electricity. The moment the light bulbs close, therefore that means there is a current inside of this circuit. Now, for this only reason that there is a current is because the circuit is closed. Okay, so these are the conditions that are needed for electric current. Remember what is electric current? The charges, the rate of flow of charges. Rate simply means time. The time it takes for these charges. Remember, I said copper wire has electrons, right? So those charges, those electrons, the way they flow inside of this circuit, that's what we mean by electric current, okay? So for us to have electric current, we need these simple conditions. Know what is a closed circuit, know what is an open circuit. A closed circuit, it doesn't have any opening or breakages like they're written over here. Again, a closed circuit, if there is a switch present, the switch will be turned on. Okay, so when the switch is on, therefore the circuit, when the switch is closed, we say the switch is on or the switch is closed. Therefore, there will be flow of current inside of this circuit. But when the switch is open or the switch is off, therefore there will be no flow of electric current inside of the circuit. So now we have a closed circuit. Open circuit, switch on. Closed circuit, switch off. Open circuit, don't forget that, okay? All right. Now, there are certain components that we use for electric circuits. Just for so know that you know, we have the conductor, like I said. Now look here, it's a real picture diagram, and then here it's what we use when we draw the circuits, right? We have what you call the conductor. It's a wire, which is a good conductor of electricity. It conducts the electricity inside of the circuit. So this is a real picture of how a conductor actually looks like. And then here we have the connecting wire, which is the same as conductor. These two things are the same, but this is a different presentation. This is a presentation that we use when we draw the circuits on our books. But in reality, this is how a conductor actually looks like, okay? It's a conductor which conducts electricity. Why conductor conduct electricity? Because remember I said it's a metal, a wire. It's categorized under matter and materials, right? So why it is categorized under the metals. So now what's happening is if we have the metals, they have the electrons, like I said, they have free moving electrons. So those free moving electrons, scientifically, we name them as the delocalized electrons. We call them as the delocalized electrons. Now, another component of circuit is resistor, okay? This is a simple diagram of this is a real diagram on how a resistor actually supposed to look like, okay? And then here, it's a schematic diagram on how we draw resistors. I mean, like, for example, if I ask you to draw a diagram right now, not a diagram, if I ask you to draw a circuit that has a resistor in it, you won't be able to draw this. So what do we use as scientists to represent our diagram in a form of drawing? So meaning if you want to draw, this is the first way you can draw your resistor in this way, which is still fine, it's correct. It represents the resistor. You can draw your resistor in this way, which is also fine. Or you can draw your resistor in this way. It really does not matter which form you want to use when you want to draw your diagram. So that means in future, when you are given a circuit, and then you see this kind of pictures, I mean, this kind of diagrams, just know that we are actually talking about the resistors in a circuit. And then what does the resistor actually do? We know that the resistor, it resists the flow of charges in a circuit. What I said to you over here is that I said to you, here we have a simple schematic diagram of a simple circuit. And I said that because we have the flow of charges on this copper wire, we have the flow of charges, which are the electrons. They flow, they flow, they flow. That's why this light, it is bright. It's because those charges, they are continuously flowing, 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 flowing. But you have to understand that even light bulb, it serves as a resistor, okay? Meaning it brings resistance in a circuit. Simple term of English. When you talk about the resistor, what are we actually talking about? The resistance. Resistance is something that disturbs the flow of charges. So if there is a resistor in this circuit, therefore the flow of these charges, it is going to be resisted, meaning it's going to be disturbed, okay, by the resistor. So now that's a resistor, and another component of a circuit is a light bulb. This is a real picture of how a light bulb actually looks like. And in here, we have a presentation of a light bulb when you draw it under the circuit. This is how we draw a light bulb, okay? And we know that a light bulb, it actually converts electrical energy into a light energy, okay? Those electrons that are flowing inside of the closed circuit, they bring about electrical energy. But because there is a light bulb, what it does is it converts that electrical energy into a light energy. At some point, it also converts electrical energy into heat energy, because at some point, when there is I mean, like, I'm sure you have all tried this. Have you ever touched a light bulb that is connected in, I don't know what is it called. And then when you touch that light bulb, it feels hot. You know why it feels hot? It's because the light bulb actually converted that electrical energy into heat energy. But you don't have to go deeper and understand why, what not. It's just so you need to understand that a light bulb can convert electrical energy into a heat energy. Also, not only heat energy, the light bulb also converts the the electrical energy into the light energy, okay? So that's another component. Now let's have a look at another component. Over here we have we call it a battery, or you can call it a cell, okay? So now this is how a battery or a cell in real life looks like. I know we are all familiar with the picture. We know how this a battery or cell actually looks like. And then here we have a diagram that we use to represent a battery or a cell when we draw a circuit. On a circuit diagram, this is what I would expect you to draw. Don't draw me a complete battery over there when I say to you, draw me a circuit that has a battery or a circuit that has a cell. This is what I expect you to draw when you draw a battery. Now, here's the thing. You need to know that a battery has two different terminals or different ends, okay? The first terminal, we have the positive terminal, and then we have the negative terminal. Let's have a look at this diagram over here, so that you guys don't confuse these things. The positive terminal, I normally say tall man is positive, but mean short man, it's going to be negative. So this is a tall bar. A tall bar represents a positive terminal of a battery, and a short bar it represents a negative terminal of a battery. So this side, we can see that we have the positive terminal, and that side we have the negative terminal of this battery over here. Okay, so this part, it represents this side, and then this part, it represents that side, the positive and the terminal battery. Now, I want us to talk about the direction of a current in a circuit. Say, for example, you have your battery over there, and then you have a current carrying conductor or conductor. I can just call it a conductor. I have a conductor over there. And remember, because this circuit, this is a simple diagram of a circuit, right? It's a circuit. But I want you to understand that in this circuit, because I have a battery over there, and I say to you, the tall man is positive and the short man will be negative. So this is what you need to know when you talk about the direction of a current in a circuit. A current will always move from the positive terminal, will always move, more especially when you talk about the conventional current. Okay, I'll teach you this when you get in grade 12. So when you talk about the conventional current, I'll be more deeper so that you can understand. We have the current will move in opposite direction to the charges. The flow moves in opposite direction to the charges, but that's deep. You don't have to know that. So now in this circuit, what you see here is the current will always move from the positive terminal. Let's see, we have the positive terminal. There is the flow of charges in a circuit until it gets into a negative terminal of a battery. So that means current will move from where it started and then it will end where it started. Meaning it started from the battery, there it goes to the battery once more again. But you need to understand it will move at the opposite end and then will enter again to the other opposite end. So that's how actually current works in a circuit when we have a closed circuit just like this. So current will move from positive to negative terminal, from a tall man to a negative short man. Okay. Please make sure that you understand this, because more especially when we do the questions, more especially when you have the circuits that are connected in parallel, it's going to be a little bit confusing. Okay, so you understanding how does the current actually moves inside of the circuit, it's very important. That's why I'm emphasizing on this slide over here. Okay, all right, so that's it. And by the way, a battery, it gives potential energy. Okay, I think I'll explain this. There is a slide that talks about this, but I'll explain that much more better. Now here we have another component of the circuit, but most of the times we don't deal with this component, just so that you know it's fine. This component, it is different from resistor. Don't confuse this component and resistor. Remember, resistor doesn't have this arrow over here. So this is the real picture on how the rheostat actually looks like. We can call it the variable resistor or rheostat. It also works like resistor, by the way. But this one, it controls the resistance, whether you want high resistance or you want low resistance. That's what a rheostat actually do in our circuit. But now the difference is between the resistor, when we draw them, just know that the rheostat, we draw it like this. So most of the times, you're not going to deal with this component. I'm just showing you so that you don't get confused between the rheostat and the resistor, where, more especially when we are drawing them up. Okay. So this is one examples of the other components that we have just learned. Okay. All right. Now, on this one here, we have another component which is called switch. This component right here is called switch. I believe we are all familiar with this component which is called switch. So this is how the switch actually looks like, but yeah, this is how it looks like. And therefore here, this is how we draw a switch in a circuit. Okay, this diagram over there, this is how we draw a switch on a circuit. So in this case, we have an open switch. Why is the switch open? Because we have a loop, or we have a space or a gap between here. So that means if you have an open switch in a circuit, let's have a look at this circuit over here. Here's our switch. We have two switches. Let me just draw an arrow so that you can see them. We have switch over here, and then we also have switch over there. I don't know if you can see them. Now, these two switches, to us, they are closed. But if this switch goes up like this, you see this portion over here, if it goes up like this, now the switch will be open. So when we have an open switch, the charges in these electrons won't be able to flow because the switch, it is open. There won't be a flow of electric current inside of this circuit. But when we close the switch, when we close the switch, like here, the way this switch it is, that means this switch it is closed, this switch it is also closed. That's why we have the electric current flowing inside of this conductor. We know that the electric current will flow from positive terminal, go through the resistor. Look at this is a resistor. Will go through resistor and go back to the negative terminal of the battery if the switch it is closed. But when it's open, there won't be flow of electric current inside of this conductor or inside of this circuit. I've already explained. This is how in life, this is how switch or open switch looks like. And this is how the closed switch looks like. And then if it's closed, we'll do it like that. See, I tried to draw a line there to show that this switch is open, this switch is closed. So I've already explained this, okay? All right. Another component of a circuit is voltmeter. What voltmeter do is it produces, don't confuse these terms, okay? Don't confuse these terms, and I'll explain to you what does the voltmeter do. Voltmeter, it produces what you call the voltage. Voltage, okay, let me erase that. Voltmeter produces what you call the voltage. The voltage, né? Or if we don't call it voltage, we call it the potential difference. We have the potential difference. If we don't call it the potential difference, you will see, more especially when you get in grade 12, okay? We call it EMF. We call it EMF. Normally, EMF it is abbreviated for electromotive force, but you don't need to know that. You understand this when you do electrodynamics, okay? But not now, okay? So now here's but EMF is just the total voltage a battery can give. If you go, we have a battery, right? You guys are familiar with a battery, right? This is a battery. You guys are familiar with this. If you have a battery, just go, I know you have remote controls at home, the ones that you use for your TVs, right? When you have a look at this battery, this cell over here, there is somewhere where it is written 1,5 V. This 1,5 V, you know what does that mean? 1,5 V, it simply means the total voltage a battery can give to a circuit. So it is also referred to as EMF, okay? That's what we mean by EMF. EMF is a total voltage a battery can give or a battery can supply, okay? So a battery, it actually gives voltage. And then the other components, such as resistor, such as light bulb, such as rheostat, all of those components that we have just mentioned, you can measure the voltage around them. But remember, a battery can give a voltage to a circuit, but the other components such as rheostat, such as resistor, and all of those, we can measure the voltage around them. They use voltage while the battery gives the voltage. Like for example, I am a battery and you are rheostat. So one of you is a resistor, one of you is a light bulb. So because you guys, I'm gonna give you the voltage, and the voltage that I give to you as a battery, you guys, you're gonna share that voltage that I'm gonna give to you amongst yourselves. Again, that will also depend on a connection of a circuit, but you'll see, it's fine. You'll understand what I mean by that, okay? So voltage is this is how it looks like in real life. But also this is called multimeter. Ne? I have this, it's used to measure, you can measure voltage, you can measure current, it's called multimeter. Ne? Okay, by the way, this is how you measure the voltage. You see this guy, what he did over here is he took a battery, right? And then he took these connecting wires and then he plugged them on the voltmeter. So you know what we use to measure the voltage? We use the voltmeter. Ne? Oh, I made a mistake, I think. So let me re-explain this. A voltmeter is a device that measures voltage. Did I say that? I hope you don't confuse these two words, voltmeter and voltage. Voltmeter is a device, ne? Device. It is a device that measures, this is how a device looks like. It's a device that measures voltage. It measures voltage, ne? Voltmeter. And then we have the voltage, which is what I've just explained. And the units for voltage, we say it's volts. We say it's volts, which is denoted by capital letter V, is volts. We have voltmeter, which is the device. We have the voltage, which is potential difference or EMF a battery can give. And then we have the volts, which are the units that we use to measure the voltage. I think we're still gonna discuss this again, okay? And therefore, this is how we draw the voltmeter, the voltage, sorry. This is how we draw the voltmeter of the circuit. Okay, a voltmeter of a circuit, which measures the voltage. Don't confuse these things. And then we have another component, which is called the ammeter. Ammeter, it is also a device. Okay, ammeter, it is also a device that we use to measure what? This one, it measures the current. Okay, so ammeter measures the current in a circuit. If we want to know how much is the current that is flowing through the circuit, we take our ammeter and then we measure that current. Therefore, our ammeter will tell us how much current it is actually flowing inside of the circuit. Okay, and then the units that we use for current, we use amps or we use amperes, okay, which are denoted by letter A. We use amperes. Okay, right. So this is how we draw an ammeter on a circuit. This is how an actual ammeter looks like. Okay, right. And therefore, this is multimeter. Oh, I have this one. Shokomelo's sister once gave it to me. That was Maggie. So this is what we call the multimeter. So what multimeter does is you can use it to measure the current, meaning it's multimeter. It can be voltmeter, it can be ammeter. You understand? Multi means many, right? Multiple. So meter, you can have voltmeter, you can have the ammeter. So meaning multimeter can measure current and also it can measure the voltage. Okay. So that means this is not a multimeter. Oh, it looks like multimeter though. So, but this is not a multimeter, it is specifically voltmeter. Okay, it's 2-in-1. Right. So I hope we all understood all of the components of the circuits and how the components of the circuit actually looks like and how we represent these components of the circuit.